Hello all, good morning. This is Dr. S. Subbalakshmi, Assistant Professor in the Department of Mathematics, SNS College of Technology. This is a case study video on an evolute of a given curve. In the previous video, we have seen the design thinking approach on the evolute of the given curve. Now we will have our students to explain each and every slide.
Design thinking approach. Empathize. Astronauts need a sharp images and optical engineers need a precise curvatures. Even a tiny error causes a large focal distortions. Define. Identify points where the radius of the curvature differs from the theoretically. Compare actual curvature center with the evaluate. Quantity of the surface here.
Quantify surface error tolerances. So this is our defining the empathy part.
Ideate. Calculate the curvature of the parabola. Compute, evaluate to get the center of the curvature path. Compare the actual mirror curvature to ideal. Evaluate, generate a repair strategies.
So in ideal process, we will be calculating the evolute of the parabola of the given concept here, given system here, and then we will start. We'll make a strategy to find the errors rectified.
Prototype. Create a curvature error map. Use interferometry to measure the deviations. Apply localized polishing corrections.
So in the prototype, what we will do, we will make corrections regarding the same. Whatever errors we have, those things are to be rectified in the prototype process.
Test. Perform ray tracking simulations. Measure focal accuracy. Verify reduction in optical aberrations.
So in the testing process, what we will do, we will test for ray tracing simulation. Simulation has been done here for ray tracing, and the second thing is the focal accuracy is also measured, and the third thing is we are verifying that whether there is any reduction in the optimal aberrations here or not. This is our design thinking approach on our case.
Case study 1. Highway curve safety using evolute of the curve. Curve y is equal to ln into x. Real time problem. Highway follows curve y is equal to ln into x. Driver struggle with sudden bends. Urban curvature is equal to gives accidents. Need to identify dangerous curvature points. Evolute helps locate centers of curvature.
So what do we have here? We are going to study a point on the highway curve safety. Using our evolute of the given curve. So our curve will be y is equal to ln x. With that curve on hand, we are just evaluating what this particular highway follows the curve, or the driver struggle with sudden bends or not, or the abrupt curvature, which means the sudden curvature falls for the accidents, and we are in need of identifying the dangerous curvature points here, and this will also be done by the evolute steps.
Why evolute is needed? Shows curvature behavior along curve. Identifies sharpest turning zones, helps engineers smooth the road design, ensures driver safety and control.
So why our evolute is needed is studied in this slide. We are in need of the evolute which shows the curvature behavior along the curve. So along the total curve, which shows the behavior of the curvature along the total curve, which is y is equal to ln x. And the second point is it identifies the sharpest turning zones. So where the curvature is high, that will be called as the sharpest turning zones. And the third is it helps engineers smoothen the road design. So it helps the engineers to smoothen the road design where the curvature will be very slow and we will be reducing the accident prone areas, and ensures the driver safety and the comfort for driving. So these are the things to be noted and why we are in need of an evolute.
Mathematical evaluation. Y dash equal to 1 by x, y double dash equal to minus 1 by x square. Curvature k equal to modulus of y double dash divided by 1 plus y dash square whole power 3 by 2. Evolute coordinates x equal to x minus y dash 1 plus y dash square divided by y double dash. Y equal to y plus 1 plus y dash square divided by y double dash.
Okay, this is the mathematical evaluation concept wherein we will be having the formulae of the evolute concept, where we have the curvature here, and in the next 2 points we have the x bar and y bar centers of curvature.
Key observation. Maximum curvature near indicated short turning point. Evolute cluster near dangerous zone. Road winding and banking needed.
So these are the key observation points noted in the highway safety area. Maximum curvature near to be noted and indicates the sharp turning point. The curvature indicates the sharp turning point. It evolute clusters near dangerous bend. So evolute, which means evolute is a curve which clusters near the dangerous bend, and road widening and banking is also needed in the key observation.
Engineering solution. Smooth and curve transition. Increase radius of curvature. Add supervision banking. Reduce steering strain.
So these are the solutions given for the engineers using our evolute concept. So the final here is danger zone is eliminated in the evolute concept and safer navigation can be provided and improve the diversity and reduce the accident rates have been found in the as a final outcome.
Designing a parabolic mirror using the evolute curve y square equal to 4ax. Real-time problem. Parabolic mirror must focus all light at one point. Small curvature error to image blur. Need perfect curvature along entire mirror. Evolute guides precision shaping.
So this is our case study, second case study wherein we have a parabolic mirror which has the equation as y squared is equal to 4ax and we are in need of these all things as the problem here.
Why evolute is important? Evolute gives path of curvature centers, identifies where grinding must be adjusted, ensures accurate reflection, essential for telescopes, antennas and headlights.
So this type of parabolic mirror have been applied in all these kind of telescopes, antennas and headlights whereas we will be having a concave shaped parabolic mirror wherein we will be applying the evolute concept.
Mathematical evolution. So y square is equal to 4ax, y dash is equal to 2a by y double dash is equal to minus 2a y dash by y square. Apply evolute formula for persistent curvature. Ensure base converges exactly focus.
So these are the formula we have applied here, y dash and y double dash we have found and what it ensures that rays converge exactly at the focus point.
Prototype or mirror design. Plot parabola on its evolute, identify curvature variation, machine mirror based on evolute points, corrects curvature deviations.
So these are the prototype in the mirror design, which is a parabolic mirror design, wherein we will be plotting the parabola with its evolute and we will be identifying the curvature variation wherever it happens and the measured mirror based on evolute points is also noted and corrects the curvature deviations here.
Final solution. Perfect focal point achieved, clear image quality, high accuracy in telescope, improved optical performance.
So this is the final solution we received in the parabolic mirror with the help of the evolute. What we have inferred is we have got the perfect focal point which has been achieved through the evolute concept and a clear image quality. Image quality have been noticed to the much precise one and high accuracy in telescopes. While using the telescope there is much high accuracy we found and the improved optical performance in the telescopes or the antennas or the headlights we take as a system. On the whole, what we summarize here as a case study means we ensure that this evolute ensures that there is a correct curvature for the given curve. So that we will ensure our stability or the comfortness or the things what we are in need of are empathizing part. Second thing is it prevents the optical distortion. So whatever if there is any relevant changes in the optical things, we will be avoiding all those things or ignoring all those things. Wherein we have this engineering concepts plus the calculus concepts which will result in the precision design. The precision design implements with a well-behaved format. And the next thing is the students can be appreciated in math in the real-time applications with this help of case study. Thank you.